Hello class, we're ready to begin a new chapter, and our new chapter deals with a topic called quadratic functions and equations. Quadratic functions and equations. This is not really new to you because we've been dealing with this in chapter 8 quite a bit. So the standard form of a quadratic equation, you already know that it's ax squared plus bx plus c, and in this case, we set it equal to f of x, a function of x, being ax squared plus bx plus c, where a, b, and c are each constants. We call them these two here are the coefficients. This one, a, coefficient of x squared, b, coefficient of x, and c is a constant that's added onto the end. So this is standard form. Now you know in chapter 8, we often set this equal to 0. We factored this to solve for the values of x, which would give us f of x equal to 0. Or sometimes we called those the zeros of the function. Sometimes we called them roots or solutions. So standard form looks like this. When you have this type of an equation, the graph has an interesting shape. The graph will be it will be in the shape of something known as a parabola. So I'm going to show you a couple of examples here of parabolas, and let's just see what they look like. So I'll put a graph paper down here. Let's make ourselves a little chart of x and y. So here we go. We'll make ourselves an axis on here, like so. We'll call this f of x up here, and we'll call this x, our x-axis, and our y-axis, except that our y-axis in this case is f of x, the value of our function. Remember from way back, we often said that f of x equals y. It's another way of naming our y-axis. So let's take the simplest form of our quadratic equation. So let's take a look here again at f of x equals ax squared plus bx plus c. Let's let b be equal to 0. Let c equal to 0 as well. So b and c are both 0 and a equal to 1. If a was equal to 1, then it would just be x squared. And if these are 0, then we'd have f of x equals x squared. This is our example then, what we would like to deal with. Let's take a look at this. F of x equals x squared. And let's make ourselves a little table of x and f of x. X and f of x. So here we go, x and f of x for f of x equals x squared. Let's put in 0. 0 for x, 0 squared is of course 0. It turns out that I can put in either positive or negative 1. If I put in positive 1, 1 squared is 1. And if I put in negative 1, negative 1 squared is also 1. So plus or minus 1 both give us 1. Plus or minus 2 both give us, that's right, 4. And plus or minus 3, what am I doing? Plus or minus 3 would be equal to 9. Okay? Plus or minus 3, 9. So let's graph these points. 0, 0, right here, origin. Okay? That's 0, 0. How about 1, 1? Well, 1, 1 is here, or negative 1, 1 is here. So either plus or minus 1, we both get 1 out for our y coordinate. If I put in plus or minus 2, here's 2, and then would be 4 right there, and another 4 over here. Okay? And then if I put in plus or minus 3, 3, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, all the way up here. So notice I was 2 units to the right, 2 units to the left, 1 unit to the right, 1 unit to the left. Up here, 3 units to the right and 3 units to the left will bring us right here. So plus or minus 3, plus 3, minus 3, both give us 9 units up. Notice this graph. The shape of this graph Okay, it's a little tough to draw these things, but I'll do the best I can. Freehand. Okay, it looks like this. This equation has a special shape. The shape is called a parabola. Parabola. I had a teacher once, he said, this is a parabola. I don't know what bolas are, but it's a pair of bolas. So there we go, a parabola. So this is the shape of this graph. Now, the thing that's interesting about the graph, it is symmetrical. It is symmetrical. It is symmetrical about this line, the vertical axis in this case. If you were to fold the paper right down this line, you would see that this left side falls on top of the right side. Just imagine that you fold it right in the middle, fold it together, fold it, and you would see that these two halves fall right on top of each other. Provided I drew it perfectly anyway, they would fall right on top of each other. So it is symmetrical. Now, it is symmetrical about this line called the axis of symmetry. So this line right here is called the axis of symmetry. Now, the axis of symmetry can be found. You can find the equation of it. It's a straight line, you agree? What is the equation of this line? X is equal to, if you look at our x, this is the origin. If you look at our x-axis, this has a value of 0. And no matter where we go, up or down, what's the x-coordinate? It's always 0. So this thing has an axis of symmetry of x equal to 0. That's our equation for the axis of symmetry, x equals 0. So no matter what y is, you can go high or low, it's always x equal to 0. So let's get some terms down now. One we've already identified, axis of symmetry. This is a parabola. It's symmetrical left and right, and this is called the axis of symmetry. What is this point down here called? Let's look at this point down here. This one, right here. This point is called the vertex. That's our vertex. And in this case, since this graph is opening upwards, the vertex here represents the lowest point of this quadratic function. F of x equals x squared, this is the lowest point. Or what's another word for the smallest value or the lowest? We would call that a minimum, wouldn't we? So this vertex represents a minimum. Now it turns out that when we deal with quadratic functions, the vertex will either be a minimum or a maximum. Now we'll do some maximums in a little bit, but if this thing were flipped over, so if it were opening downwards instead of upwards, if these points here were going down, then the vertex would represent a maximum value. So here we have then parabola. We've learned about standard form. We've learned about the axis of symmetry. We've learned about the vertex. And we've learned that the vertex represents either a minimum or a maximum. So let's take another example. And let's change the a. Remember, what was the value of a for this here? Remember, ax squared plus bx plus c, in this case a was equal to 1, 1x squared. And b and c were both 0. That's why you don't see any x or any constant added onto this equation. Let's take another example. Let's flip it around and do another one that is almost the same but slightly different. So let's just take this graph and extend it on down here. And let's go this direction here for our horizontal axis. And let's label this again, f of x up here. And let's now deal with the graph of f of x equals minus x squared. So notice a equals -1, b equals 0, and c also equals 0. And I'm talking about here our standard form of f of x equals ax squared plus bx plus c. F of x equals ax squared plus bx plus c. In this case, a, -1, b, 0, c, 0. And we have f of x equals minus x squared. So let's graph this one. Okay, again, we make ourselves a little table of x and f of x. So we put in 0, we get out 0. If I put in plus or minus 1, we get out 1. Plus or minus 2, we get out -1. Plus or minus 2, we get out -4. And plus or minus 3, we get out -9. Why are these negatives? Because there's a minus sign in front of the x squared right there. It's minus x squared. So, plus or minus 1, 1 squared is 1. -1 squared is also 1, but there's the minus in front to change it back to -1. Plus or minus 2, what's 2 squared? 4. But then you have the minus sign in front to make it -4. Plus or minus 3, put in 3 squared or -3 squared. It's 9, just the same either way, but you have the minus in front to make it -9. So in this case, start graphing. This will be our point right here for 0, 0, then 1, -1, -1, -1, 2, -2, 2, -4 right here, and -2 would also be -4 right here, and then I can put in 3 and I get -9. That's 4, 5, 6, 7, 8, 9, and 3 on the other side over here, -9 over here. So the graph goes down like so. Okay, going down like this. Okay, so this point again is our vertex, and in this case it is a maximum. Maximum, and this is our vertex. What are the coordinates of the vertex? The vertex has the coordinates of 0, 0. Just like up here, it also had, in this case, for this other graph, it was the same. It was vertex equal to 0, 0. Okay? Just the same up here, 0, 0. And here, in the second example, it's also 0, 0. Okay? So the catch here is that when a, right here, when a equals -1 or any negative number, the graph will be opening down. So let's see if we can't organize this just a little bit. When a is less than 0, the graph will open downward. And when a is greater than 0, the graph opens upwards. Important principle to remember. When a is negative, less than 0, it opens down. When a is greater than 0, it opens up. If you ever forget, just think about f of x equals x squared. X squared, a is 1, 1x squared, 1 is a positive number, you know it goes uphill. If you throw a negative sign in front of it like we did here, it goes down. So it's easy to remember. A is positive, opens up. A is negative, opens down. So what have we learned so far? We've learned about standard form. We've learned that this type of a graph is called a parabola. We've learned that it's symmetrical about a line called the axis of symmetry, which we had right up here. Axis of symmetry, remember? And we've also learned that the vertex will represent a minimum or, like we did here, a maximum. Now, if we would like to know the equation of the axis of symmetry, then we can do that. We can do that because there's a method of manipulating this standard form of the equation, ax squared plus bx plus c. If you manipulate this through a process called completing the square, you can put it into a form where you can identify the vertex, and the axis of symmetry comes out of that whole thing. In this case, you see that the axis of symmetry, in this problem we did here, the axis of symmetry was x equal to 0. It's, by the way, just the same down here, x equal to 0. And there's an equation for the axis of symmetry. I'm going to give it to you here. Axis of symmetry. Axis of symmetry. It looks like this. X equals minus b over 2 times a. Okay? I want to make sure that stands out well for you to see. Minus b over 2a. Memorize this, okay? Memorize this equation right here. The axis of symmetry is minus b divided by 2a. The axis of symmetry. And again, where do we get the a and the b? They're right out of our standard form, right here. F of x equals ax squared plus bx plus c. So minus b, that's the negative, the opposite of b. If b was a negative number, then the minus here will throw it back to a positive number. Just go ahead and put your a and your b in here, whatever they might be, from this equation. Choose your a and your b. Just plug them in here, b divided by 2a, and throw a negative sign in front, and you will have an equation for the axis of symmetry, x equal to something. And again, remember, x is a constant on a vertical line. Vertical lines are of the form, putting them in standard form, x equal a constant. Remember, horizontal lines, y equals a constant. Vertical lines, x equals a constant. So I think we're ready to do some examples now from your exercises that we would have you do a little later. So I'm going to just take our textbook and randomly grab some problems out of here and see if we can't answer them. Okay, so first off, they would like for us to graph a function. Okay, find the vertex, the axis of symmetry, and the y-intercept of the graph of each function. Just incidentally, what was the y-intercept of this graph? What's the y-intercept of this graph? Where does it cross the y-axis? Well, it only hits the y-axis in one point, and that's at the vertex. This is a simple case of a parabolic equation, a quadratic equation. Very simple case where the vertex is on the y-axis, but no other point is on the y-axis. So this was a simple case. Other cases are a little bit different, and they won't be quite so simple. So let me rip this paper off here, and I'll flip it up like this. And let's do some problems now. So let's take this example, and I will put up a PDF of this page so you can see it. But just for starters here, let's take the equation y equals negative 3x squared plus 6x minus 1. Y equals negative 3x squared plus 6x minus 1. Okay. Now the y, we could just as well call it f of x, couldn't we? F of x equals negative 3x squared plus 6x minus 1. Now our first job that they've asked us to do is to graph this thing, to graph it. Before we graph it, however, I would like to identify the axis of symmetry. What is our axis of symmetry? You remember the equation that I just told you to memorize? you've got a good memory, you can probably remember that it's x equals to minus b divided by 2a, which in our case is x equal to minus, okay, what's b in this equation? This is standard form, isn't it? ax squared plus bx plus c. So a is negative 3, okay, b is 6, and c is negative 1. We could write these as plus a negative 1, right? So c is negative 1, b is 6, and a is negative 3. So minus, I got my minus sign out front. Let's put our b in here now, 6. And what's 2 times a? Well, it's going to be 2 times negative 3. Okay? 2 times negative 3. So x equals minus 6 over minus 6, isn't it? So it's the opposite of 6 divided by minus 6. What's 6 divided by minus 6? It's negative 1, but then I have a minus in front of that, so it becomes plus 1. So this thing turns out that it's x equal to 1. If I want to do it in 2 steps, I can put a minus here. 6 over minus 6. 6 divided by minus 6 is negative 1, with another negative in front makes it positive 1. X equals positive 1. What does the graph of x equal to 1, positive 1 look like? Again, I need to get myself axis up here so we can talk about this intelligently. Okay. Make ourselves an axis. By the way, a is what? Negative 3. Will this open up or open down? From what we just discussed. Open up or open down? Answer, opens down. So I'm going to put this a little higher here so that we have more room to the bottom. I'll put my axis right here since I know it's opening down. Okay. So this is f of x on this axis and x. Okay. Make ourselves a little table of x and y, or x and f of x. Okay. X and f of x. X, and then the function at the value x. Value of the function at x. We could read it that way. This is the value of the function f when x equals whatever it is. So you usually start off with the easiest case you can think of, which is x equal to 0. Let's put 0 in here. Now look carefully. 0 squared is 0, so this term's gone. 6 times 0, also 0. These two terms are 0, and we have then x equal to, y equal to negative 1. Notice when we put in 0, 0 squared is 0, so this term 0 plus 6 times 0, which is also 0, then we subtract 1. So 0 subtract 1 is negative 1. F of x equals negative 1 when x equals 0. Okay? Now let's put in another one. Let's put in, how about 1? Okay? What's 1 squared? Okay? 1 squared is positive 1 times negative 3. Maybe I should write these things out so that you can see it. Let's do it this way. Y equals negative 3 times 1 squared plus 6 times 1 minus 1. So negative 3 times 1 is negative 3. Okay, plus 6 times 1 is 6, plus 6. Okay, subtract 1. So notice here we have negative 3, subtract 1 is negative 4, plus 6 is equal to 2. So when we put in 1, we get out 2. Okay. What happens if I put in negative 1? Let's try a negative 1 and see what we get. Negative 1. Okay. Y equals negative 3 times negative 1 squared plus 6 times negative 1 minus 1. Okay. Putting in negative 1. Negative 1 squared is positive 1 times negative 3. Positive 1 times negative 3 is still negative 3. Okay? And then plus 6 times negative 1, which means subtract 6, and then subtract 1. What do we get out when we have negative 1? Well, it's 6 times negative 1 minus 1. Okay, that's minus 6, minus 12, minus 3 again, and we get minus 15, isn't it? Minus 15. Is that correct? Okay. Negative 1 squared is, again, positive 1, just checking ourselves, times negative 3, okay, is negative 3. Subtract 6, subtract 1. So the first two is negative 9 minus another 6, negative 15. So we put down minus 15. Okay. So let's graph these points so far. What do we have? First off, what do we have here? We have 0, negative 1. So it's this point right here. That's 0, negative 1. These are ordered pairs, right? X, Y. Then we have 1, 2. 1, and we have the point 2 right here. And then if I have negative 1, I have negative 15. Look at this. Negative 1, I get negative 15. 1, 2, 3, 4, 5, 6, 7, 9, 10, 11, 12, 13, 14, 15. Wow, way down here. It's kind of off the view of the camera here. Way, 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 way down. So notice how this graph is going. Very steep. It's going like this. Something like this, going down. Okay. And so I can see then, what was our axis of symmetry? Do you remember? X equal 1. So that means right here, x equal to 1, this was our axis of symmetry. Let me put a little dashed line down there to represent our axis of symmetry. This guy right here, x equal to 1. This is our axis of symmetry, x equal to 1. Okay? So that point right there, 1, 2, should represent what? Our maximum, shouldn't it? That should represent our maximum right there, maximum. So if you think about it, if I put in 2, okay, when I put in 0, I got negative 1. When I put in 2, I should get also negative 1, shouldn't I? Because it's symmetrical. So think about this. This is my axis of symmetry. The point 1, 2, 1, 2 is right here on the axis of symmetry. If I go 1 to the left of this point, 1 to the left, I go down to here. If I go 1 to the right, I should also go down to here. So this point should be on the graph, meaning the point 2, negative 1 should be on the graph. Let's check it out and see if that is in fact the case. So let's put in 2. What do we get out when we put in 2? Trying to keep all this in view for you in the camera. Let's do this. F of 2 is equal to, okay, going back to our equation, it's going to be minus 3 times 2 squared plus 6 times 2 minus 1. So 2 squared is 4. 4 times 3, 12, but there's a minus sign in front of it, so it's minus 12. Minus 12. Plus 6 times 2, which is positive 12. And then minus 1. So what's negative 12 plus 12? 0, subtract 1, or just minus 1. So f of 2, value of the function when x equals 2 is equal to negative 1. So 2, we get negative 1. Interesting, huh? Notice when we had 0, we had what? Negative 1. And 0 was how far to the left of the axis of symmetry? When x equals 0, we are 1 unit to the left of the axis of symmetry. And the value was right here, negative 1. When we go 1 unit to the right of the axis of symmetry, we should have the very same value. And we do. Notice this was 1 unit to the left, which was 0, negative 1. 1 unit to the right is 2, negative 1. So right here. So this is 2, comma, negative 1. And this point over here is 0, comma, negative 1. Okay, 0, negative 1, 2, negative 1. Okay, and it follows then that if I go 2 units to the right, notice here I went 2 units to the left when I put negative 1. How far down did I go? To negative 15. If I go 2 units to the right of the axis of symmetry, which should be what number? Here's my origin. Don't forget, this is the origin right here, 0, 0. So this 1 unit to the, or 2 units to the left was negative 1. This is negative 1, and we went down how far? To negative 15. If I go 2 units to the right, we would have x equal to, here's x equal to 0, x equal to 1, x equal to 2, x equal to 3. So if I have x equal to 3, I would get, right here, if I put in 3, I should get out negative 15, shouldn't I? Because it is symmetrical. So 2 units to the left, I got negative 15. 2 units to the right, I should also get out negative 15. So again, this is my axis of symmetry coming right down here. Axis of symmetry, here was negative 15 right here, and positive 3 right here should also have the value of negative 15. So let's go ahead and sketch the rest of the graph in here. Again, they're tricky to draw, but you know, you do the best you can. Should always be smooth curves. There's no sharp corners. Everything is smooth. And this is our maximum right here. So specifically, they asked us to name the vertex. What is the vertex? The vertex is the point 1, 2. Vertex is the point 1, 2. Okay? So that's the first part of our answer. Vertex 1, 2. Okay? Which we identified right here, 1, 2. This, I could put a little v in front of it to mean this is our vertex, and it was a maximum. By the way, what's the value of the maximum? The maximum value of the function? F of x equals 2, 2, 2. Okay, right here. The value of the function f at x equal 1 is 2. That's the maximum. The maximum value is 2. Everything else, no matter which values I choose for x, is going to be less. Okay? So that's our maximum. Our axis of symmetry, they ask us to identify that, which we did someplace. Where did I put it? Oh, yes. Axis of symmetry, we solved minus b over 2a. We solved x equal to 1. So that's something they asked for. They also asked for this, axis of symmetry. Now, they asked for one more thing. Besides the vertex and the axis of symmetry, they also wanted us to identify the y-intercept. Where does this graph cross the y-axis? Okay? Where does it cross the y-axis? Well, the y-axis is the axis here that's in black. It's this guy right here. I wish I had something that was a little more prominent, but I think you can see this. This is my y-axis. Where does the graph cross the y-axis? Well, it's we know that when we put in the value of 0, we got out negative 1. 0, we got out negative 1. Right there. 0, negative 1. Does that make sense? Zero, negative 1. Right there. That's my y-intercept, isn't it? 0, negative 1. Now, here's the interesting thing. The y-intercept will always occur at the value of the function where x equals 0. Okay? Think about it. The y-axis. Here's our y-axis. You don't cross the y-axis unless the value of x equals 0. So look here. Here's our x-axis. The value of x must be 0 in order to be crossing the y-axis. In other words, if the function is crossing the y-axis, then the value of x must be 0. It's just kind of logical, isn't it? When x equals 0, you have your y-intercept. So how do you find that? Well, it's pretty simple. If you want to, now here we already did it by graphing, but if you really wanted just to identify the y-intercept, you would do something like this. You would say it's the value of the function f, okay, value of the function f when x equals 0. So what's f of 0? Well, it's minus 3, we did this earlier, times 0 squared, okay, plus 6 times 0 minus 1. And what did we get out? This is all 0. We just get out negative 1. So we got our point there of 0, negative 1. 0, negative 1. That is our y-intercept right here, y-intercept. Put a little line there and label this as y-intercept, okay? 0, negative 1, okay? 0, negative 1. Well, that answers that question pretty well, and I think we can move on to another example. That's quite a thorough example. It deals with a lot of stuff. I hope that it makes sense to you. Let's see what else we can find in this book that looks challenging. Let me see. How about this one? So we have somebody, this is going to sound very familiar to your test, huh? We have somebody that throws a ball into the air, and the height of the ball in feet can be modeled by the equation y equals negative 16x squared plus 16x plus 5. Okay, so let's get us a new sheet of paper here and proceed to solve this guy. Okay. So here's the equation again. The height of a ball can be determined by this equation. Y is equal to negative 16x squared plus 16x plus 5 plus 5, okay? Where y represents the height of the ball at x seconds. Now, you probably would like this to be written differently, wouldn't you? You'd probably prefer it to look like this. And again, you can represent things in many different ways. We could also write this as follows. We could say that this is the function f of t. You don't have to do this, but I'm just showing you. We could write it that it's a function of t, where t is time. So this would be minus 16 t squared plus 16t plus 5. And f of t would be the height, and we could name it h. h equals minus 16 t squared plus 16t plus 5. We could name it like this, couldn't we? And there, if we did it this way, then t would represent time, and h would be height, or the function at the value t being the height. And maybe this would seem a little more logical, and if we were doing more of a physics problem, it would probably be in this form. And we did problems on the test like this and in our examples from last chapter. But in this case, they just use x and y. Okay, and y, of course, is f of x. It's the same thing, doesn't matter. It doesn't really matter which way you represent it, but just saying, don't forget this, that it could be t is time. So here we go. The question specifically asks us to do the following. Okay, graph the equation, number 1. And number 2, or A is graph the equation. B is what is the height of the ball from what height was the ball thrown, and C, what is the maximum height of the ball. Okay. Well, first off, let's ask ourselves the question, does this graph open up or does it open down? Take a look, up or down? Minus ax squared plus bx plus c, where a is less than 0, a is negative. Remember, when a is negative, the graph opens down. Graph opens down when a is negative. Let's see if we can't get some things on here to get this graphed. Okay, there's our axis there. Make another line across here for our horizontal axis, maybe here. Actually, let's do it here. Okay, so this is f of x, or y equals f of x, right? And this is x. And because of the nature of this equation, 16x squared plus 16x, the numbers are kind of big. And so I'm going to let every mark be probably 5 units, okay? Every mark be 5 units. Otherwise, I'll probably run out of space. That's what I'm guessing. So let's let every mark be 5. Okay, so this is 5, 10. This would be 10 right here. 15, 20 right here. 25, 30 right here. 35, 40, like that. And again, this would be 5 going up, 10, 15, like that. And of course, this would be negative 5, negative 10 going down. What's our axis of symmetry? Axis of symmetry, x equals minus b over 2a, which is minus what? B is 16 over 2 times a. And what's a? Negative 16. 16 over 2 times negative 16. Well, 16 divided by 16 is 1, isn't it? Of course, negative 1. But this is 2 times 16, so the 16s cancel, and I'm left with 1/2. Specifically, though, it'll be negative 1/2, but then there's a minus sign out front, so it's minus a minus 1/2. So I can put minus a minus 1/2, like that. And minus a minus is plus, so x equals, here's our axis of symmetry, x equals to 1/2. 1/2 unit. Maybe my choice of units wasn't so good. X equals 1/2, that's going to be hard to graph. Yeah. This one's tricky to graph because of just space, okay? Reverse what I said. Let's let this be 1, 2, 3, 4, okay? And this will be 1, 2, just mark these out here. This would be 1, 2, 1, 2, 3, 4, like that. And negative 1, negative 2 here. And sorry for the mess, but I just chose units that wouldn't work too good. So x equal 1/2. That's our axis of symmetry. Well, if this is 1 right here, x equal 1/2 would be right here. So this is my 1/2. This is my axis of symmetry right here. It's tricky to graph, okay? Tricky to graph because of space, running out of paper, etc. And especially with the camera view, it makes it hard for me. I got to keep it in this space so you can see it. So x equal to 1/2 right here. X equal 1/2, axis of symmetry. So what do we get when we put in x equal 1/2 into this equation? What do we get out? So h, or y I should say, y equals what when I put in 1/2? Negative 16 times 1/2 squared plus 16 times 1/2 plus 5. Okay, what's 1/2 squared? 1/2 times 1/2 is 1/4. And 1/4 times 16 is equal to 4. 4, but because of a minus sign, it's minus 4. So this will be minus 4. and we add to that, what's half of 16? Half of 16 is 8, isn't it? Plus 8. And what is negative 4 plus 8? Negative 4 plus 8, and then we have to add another 5. Add a 5. So we get negative 4 plus 8 is 4, plus 5 should give us a value of 9. Okay, y equal 9. So somewhere I need to start making myself a little chart for my graph. When I put in x and I get out f of x, let's keep track of these. When x equal to a half, I chose that half specifically, and I think you'll see why here in a moment. When I chose x equal to a half, I knew that that is the line of symmetry, x equal a half. See, we solved minus b over 2a, and I got a half. On the axis of symmetry, the vertex must lie on the axis of symmetry. I would like to know where is the vertex. Okay, so that's why I used x equal a half, because I know the vertex is on this red line. So if I use x equal to a half, I got out 9. Okay, 9. Now, this is exceptionally difficult to graph. So if this is 1, and this is 2, and this is 3, I'm not going to get it on here, but somewhere way up here, we have 1/2, comma, 9. Okay, that's our vertex. It's actually outside of the view of the camera. It's way up here. 9, way up here. Okay. What if I put in x equal to 0? What do I get out? Okay, now that's an interesting point. X equal to 0. Well, you take our little equation, put 0 right here. 0 squared is 0. So this term's gone. 16 times 0 is 0. That's gone. And I get out 5. 5, right? 0, 0 plus 5 is 5. I hope you can see that. I'm running out of space here in the camera view. I'd like to keep this whole problem right here. So notice 0 squared is 0, plus 16 times 0 is still 0, plus 5, that's how I get out 5. Now, x equal to 0 has special meaning. 0 represents 0 time. So if the height of the ball was 5, when time equals 0, what does that tell you? Height of the ball was 5. 1, 2, 3, 4, 5. Actually, my vertex was 1/2, 9, but this specifically 0, 5 right here, 0, 5, represents the point from which the ball was thrown. Now, I've really messed this problem up. I'm sorry, guys, but I can't fit it in the space provided unless I have tiny graph paper, and then you could probably hardly see it. So 0, 5 represents the point from which the ball was thrown. So if I had more paper, I'm bringing this down here, the graph would go something like this, up here to a point of 9 when x equals a half. So it's very steep. I'd go way up here until I would get to, way up to 1/2, 9, this point. 1/2, 9, and then it would turn and it would come back down. Okay, so it's thrown from this point, it goes up high, and then it comes back down. So how high was the ball when it was first thrown? From what height was the ball thrown? It's right here, at 5, right there, 0, 5. That's the height from which it was thrown. What's our vertex? Vertex V, right here, 1/2, 9. What's the axis of symmetry? X equal to 1/2. Okay? And what is the maximum height that the ball goes? Well, the graph opens down. You agree? Opens down. The vertex would be the maximum. What was our vertex? Vertex is 1/2, 9. So when x equals a half, the value of the function is 9. 9 represents y. Okay? xy. So y is 9 when x equals a half. And that is our vertex, which means that is the maximum of the function. 9 is the maximum height. Okay? Are you following? The vertex is a maximum. Way up here at the top, maximum. Vertex is the maximum. The graph opens down. And yeah, I could sketch this probably a little better. Maybe let me do that just to help you out. Let me just sketch it. So let's say it's thrown from right here. It goes up high, reaches some point, and then comes back down. This point right here was the point on the y-axis, okay? And it represented 0, 5. That's the height from which it was thrown. It went up to a maximum. I'm not using the grid now, I'm just sketching. It goes up to the point up here, the vertex. The vertex was equal to 1/2, 9. So the maximum was 9. So the maximum equals 9, the value of the function, okay? And then it drops down. So what was the y-intercept? I could just throw in another question. The y-intercept was 0, 5. Now, mathematically, this graph comes on down here, okay? Mathematically, but in terms of the physical problem, we knew we threw the ball from here, so there was no graph on this side because we started counting time right here. This would be negative time, and we don't have negative time in this problem. We started counting right here. We threw the ball up, went up to a maximum, and then it fell. By the way, could it fall below ground level? If this was 5, then there's a point somewhere along here, which is 0, 0. So it hits the ground right over here. So even this doesn't exist because it hits the ground right there. So if this height was 5 right here, and this height was 9, I'm not to scale, I realize. This is the height of 9, and this is the height of 5. Okay, so anyway, rough sketch, very rough sketch. Sorry for the mess. That's the general gist of it, the whole thing. So here's another problem that I'd like to show you. Y equals 2x squared plus 4x plus 7. So you take a look at this problem. First thing you should realize is that A equals 2, B equals 4, and C equals 7. 2, 4, 7. Okay. Since A is positive, which direction will the graph open? Will it be going down, or will it be going up? This shape or this shape? Which is it? When A is positive, the graph always opens upward. Upward. Okay? So we know it opens up. What is our axis of symmetry? Axis of symmetry is x equals minus b over 2a. X equals minus b over 2a, which is equal to what? Minus b over 2a, which will be equal to minus b is 4 over 2a, and a is 2, so that's 2 times 2. So 4 over 4 is 1 minus 1. X equals minus 1, axis of symmetry. 4 divided by 2 times 2, right? 2a, 2a. A is 2. 2 times 2 is 4. 4. B is also 4. So 4 divided by 4 is 1, and then there's the minus sign in front. X equals minus 1. Now that's an interesting thing. X equal minus 1. Let's see if we can put that on our graph. Where is x equal to minus 1? Well, if this thing has a scale of 1, 2, 3, 4, 5, and negative 1, negative 2, negative 3, negative 4, negative 5, down here, x equal to minus 1 is right here. X equal to minus 1. So that point represents our axis of symmetry. Let's see if we can put that on there with a red dashed line. Something like this, okay? X equal to minus 1. That's our axis of symmetry. So, thinking about all that you've learned so far, when you put in negative 1 into the function, when you put in x equal to negative 1, okay, you will get out the value of the function at negative 1. And since the axis of symmetry is x equal to negative 1, we know that the graph is symmetrical around that point. That means that the value of the function on the axis of symmetry must be the vertex. Must be in other words, -1, and then the value of the function at -1 must identify the vertex. So what is f of -1? F of -1. Stick -1 into this equation. -1 squared is +1. 2 times +1 is 2. 2 minus 4, because -1 times 4 is -4. 2 minus 4 is -2, plus 7 is 5. You get out 5. Okay, so -1, 5, this is our vertex. -1, 5. -1, 5, vertex, okay? It's an important point. Vertex, -1, 5. So let's identify that. 1, 2, 3, 4, 5. This point right here, vertex. Value of the function at x equal -1 equals 5, which is the maximum or minimum of the function. Which is it? Where does the graph open? It opens up. Opens up. Therefore, 5 represents a minimum. So 5 is a minimum. Okay. Now, if I go 1 unit to the right of the axis of symmetry, that would be x equal to what? 1 unit to the right. This is x equal to -1. If I move to the right 1 unit, I have x equal to 0. And I get out an interesting value. This is actually the easiest one to calculate. Put in 0 right here. 0 squared, 0. Plus 4 times 0 is 0. These two are gone, right? Put x equal to 0 here. These go away, and I have y equal 7. Now, that's 1 unit to the right of the axis of symmetry. X equals 0, 1 unit to the right. What's 1 unit to the left? That would be x equal to -2, wouldn't it? X equal to -2 would be 1 unit to the left of the axis of symmetry. So you see 0 in the middle, 1 unit to the right is 0. Right here. X equal to -1 is the axis of symmetry. 1 unit to the right is 0, 1 unit to the left is -2. Okay? And I would have to get out the same value because it is symmetrical. So let's graph these points. First off, 0, 7. 1, 2, 3, 4, 5, 6, 7. This is on the graph. What I'm trying to tell you is that this must also be on the graph. Remember, it is symmetrical. Left and right, symmetrical. 1 unit to the right, we get 0, 7. 1 unit to the left, we get -2, 7. Now, I haven't proved that to you, but we can do that. Let's try sticking in some numbers. What is f of -2? F of -2. Well, 2 times -2 squared. 2 times -2 squared plus 4 times -2 plus 7. Okay? -2 squared is 4. 2 times 4 is 8 plus -8 or -8 plus 7. This is just 0. 0 plus 7 equals 7. So notice, sure enough, f of -2 is 7. -2, 7. So this point is on the graph, just like 0, 7 was. 0, 7, -2, 7. What if I put 2 units to the right of the axis of symmetry? So 1 unit to the right was x equal to 0. 2 units would be x equal to 1, right here. What if I put in x equal to 1? What do I get out? F of 1. What do I get out? It's 2 times 1 squared plus 4 times 1 plus 7. 2 times 1 squared is 2 plus 4 is 6 plus 7 equals 13. So when I put in f of 1, I get out 13. Now, if I put in 2 units to the left, I better be getting out the same thing. First of all, though, let's graph this point. 1, 13. Here's 1. Here's 7, 8, 9, 10, 11, 12, 13. Right up here. 13. Okay? Let me count those again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Yes. Now, if I go 2 units to the left of the axis of symmetry, what value of x is that? Here's x equal to -1. Axis of symmetry, x equal to -1. So I go 2 units to the left. That would be -2, -3. When I put in Negative 3 right here, negative 3. What do you think I will get out of my function? Would I not get the same thing, 13? I would have to get 13 if a parabola is indeed a parabola, meaning it is symmetrical around the axis of symmetry. I would have to. So where is that? 2 units to the right of the axis of symmetry was 13. 2 units to the left would also be 13. And if you wanted to confirm that, you could, but I've already confirmed it myself, and it is in fact 13 as well. So here's the graph. Look at this. It's tricky to graph these things, but you know, we do the best we can. I think I got off just a little bit there. Okay, so something like this. That's our parabola. Okay, now this represents the minimum. So what is our vertex? Our vertex is the point -1, 5. Axis of symmetry, x equals -1. Get this back in here for you. X equals -1, axis of symmetry. The value of the function at x equal -1 was 5. So 5 represents the minimum. So minimum equals 5. Okay? Minimum equals 5. Now there's one more thing we can talk about, and that's the domain and the range of this function. The domain and the range. Okay? What would the domain be and what would the range be? The domain is what you can put in for x. Remember, this is our x-axis. What can we choose for x? Well, even though it doesn't seem like it, if I go way out here someplace, believe it or not, if I went high enough, high enough, way up, I would eventually meet this curve. Okay? It's going to be way up. And if I go way to the left over here someplace, if I go high enough, eventually I'll meet this curve. So the domain is equal to the set of all real numbers. Okay, that's my domain. The domain is the set of all real numbers. So that's what we put into the function. It's the values of x that are allowed. We can use any value of x that we like, all real numbers. What about the range? What about the range? Well, the range is a little different. The range is y, or f of x. Either way, you could put y or you could put f of x. Y such that y is greater than or equal to our minimum, 5. Can we get a negative value out of this function? No, we cannot. We only get values that are greater than or equal to 5 because 5 is the minimum. Everything else, anything on this red graph is above 5 or equal to 5. So the range is y such that y is greater than or equal to 5. So domain and range. It's another thing to consider, and I hope that this problem brings clarity to anything that you hadn't understood so far. I think this is a good introduction for our first lesson on quadratic equations and functions, graphs of parabolas, and the various things about those. Again, vertex will be either a minimum or a maximum there, and we know that there's an axis of symmetry around which the graph is symmetrical. If you fold this paper on the red line, these two halves should fall on top of each other if I had graphed it very well. So what else could I say? Standard form. Remember, standard form is ax squared plus bx plus c. This little example here was in standard form. It was good. Okay. That was standard form. f of x equals ax squared plus bx plus c. And don't forget, you are to memorize this little equation for the axis of symmetry. X equals minus b over 2a, minus the quotient of b divided by 2a. There you go. I hope that will help you to solve your problems that I'm going to be giving you. I'm going to put a little assignment up for you to work on. So good luck and study hard. If you have any questions, don't forget to message me through the message app that's inbuilt in Moodle. Up by your name, just to the left of your name, in the upper right-hand corner of your screen, you will see a little blurb there, a little circle for chat. You can message me through that, or you could WhatsApp me as well. Since we made a WhatsApp group, you have my contact there as well. Blessings to you all. Until next time, happy studying.